Hello everyone, welcome. We've got dozens already rocking up and we've got dozens more who are on the list. My name is Corey Watts. I'm a policy advisor and dog's body with Farmers for Climate Action, and I helped a little bit last year with a masterclass on climate smart farming. We had some Taswegians very active in that, and we know we got folk down there, and I'd like to welcome quite a diverse bunch of people we have who've joined us. Really good to see a lot of farmers, but also many others in the community as well, and in government and the private sector. Okay, so it's duty bound for me to introduce you to the systems we're using, and I think today we're just using this system, which is great, so I don't have to think about anything else. It's also it falls on me to acknowledge country, so I'd like to acknowledge the traditional owners of the lands on which we are meeting. Strange days indeed with Zoom. Their elders past and present, and any elders who might be present as well. Welcome and thank you. And also thank you and welcome to board members who are joining us today. I know there's at least one. Thank you for joining us, and I hope you enjoy it. And a little bit about FCA if you haven't encountered us before. So we were just chatting before in the before we got started. Farmers for Climate Action started about 5 years now ago, and it really is the only farmer-led non-government organisation that's dedicated to promoting climate action on farm and more broadly in Australia. Understanding that there are opportunities for farmers, and farmers should and can be part of the solution, and to change that narrative where farmers are seen as part of the problem only, and where many farmers are fearful of what might happen to them. So we're trying to create opportunities through policy advocacy, but also through empowering farmers so that their voices are heard, and many farmers have spoken up around the country since FCA was formed. We also do, because when it was started, lo and behold, there was a massive gap and a massive demand from many producers around the country for information on what they could do on their property and in their community. And so we do a little bit of this. We do a lot more of this actually than we've done in the past. So this seminar today is focused on perennial legumes for boosting beef productivity, and our speaker will tell us why that's important for climate change and resilience and so on. And it now falls to me to introduce Rowan. So Rowan Smith, Dr. Rowan Smith is from the Tasmanian Institute of Agriculture, where he's a research fellow. We're very lucky to have him. He's described as an early career researcher, which is a bit annoying because I'm an early career researcher. I'm just about to embark on a PhD. Rowan's actually young, but he has a wealth of experience, both in Tassie, where he's from. He's a Northern Tassie lad. And also he's studied a bit in Norway, and he was just telling me about that experience. He leads the herbage development program at TIA, and he mainly works on low to medium rainfall grazing, promoting the science, the best science around integrating perennials and legumes into those systems. And he's a curator at the Australian Pasture Green Bank. Have I got that right? Thank you. And he also works on development projects, beef production projects in Vietnam as well. So Owen, beg your pardon, Rowan. We'll just call you Owen from now on. Rowan, can I hand over to you and get your name right?
Thanks, Corey. Let me see whether I can just share my screen here.
Rowan, just while you're doing that, I'm also supposed to pre-chastise people for just make sure your microphone's turned off unless you're speaking. Otherwise, we're going to turn it off for you. Thanks so much.
Can you see my screen yet?
Yes.
Yep, you can see that?
Yep.
Good. Well, thank you very much for the invitation. a couple of weeks ago, I was able to show a few of the farmer members around our experimental site at Campbell Town in the Midlands of Tasmania. So, due to a couple of things, I guess I wasn't able to show a presentation, and so the farmers were reasonably interested in that. And speaking to Fiona and Claire, we thought that perhaps giving hopefully a shortish seminar might be a good way to get that information both to them and people around Australia. So thanks very much for the opportunity. I guess where I'd like to start is just talking a bit about farming systems in Tassie and particularly our low to medium rainfall zone of pasture systems in Tasmania. And let me just, is that catching up or not? Nope. It's not scrolled to the next screen yet, has it?
Has our design thinking?
Yep.
Yeah.
Right. Okay, good. Go back one. So for people that haven't been to Tasmania or don't really understand our pasture systems in Tassie too well, I just thought I'd put this slide up just to highlight the fact that yes, we are green a lot of the year down here, but we do have a large amount of our grazing land that sits in what I call medium to low rainfall zone. And so that green area on the left-hand side there really shows the area of pastures in Tasmania. And then on the right-hand side, that's overlaid with our rainfall. So you can see that a lot of that red area on the rainfall map overlays quite neatly with a big chunk of that pastoral or pasture lands in Tasmania. So while you probably see from a mainland's perspective looking down on us as lush green dairy pastures, that's not the total story down here. We do have a lot of medium to low rainfall, which then becomes sheep territory, sheep and beef. And so what we did about 10 years ago was a survey across the state looking at the state of our pastures from a botanical composition standpoint. Pardon me. And what we were seeing was that the botanical composition of our pastures left a lot to be desired. So it had a lot of weedy, in particular weedy grasses, whether that be annual or perennial, broadleaf weeds in general. So that really only half or a bit less than half of the pastures were actually optimal for production as from a productivity point of view. The other thing that's been happening in Tasmania is that we've had significant investment from the state government and the federal government and private industry and private landholders in investing in irrigation developments. And that has meant that we've seen an intensification of our farming systems on sections of land that has been suitable for irrigation. I think the intent of the irrigation initially was to grow a lot of crops, but what we've seen in the strong animal prices, whether it be beef or lamb, has meant that farmers have shifted into that or stayed with animal industries as well, which has meant there's quite a lot of pasture under irrigation. Now, to maximise that potential under that irrigation, we've needed animals, and I saw and a few people have seen the need to try and increase the productivity, or at least the feed base that's not under those irrigated areas. So if you think of only 10% being under irrigation, there's a lot of other land out there that can be improved, and that was going to drive a fair bit of the, I guess, reproductive enterprises to be able to then have the stock to be able to finish them under irrigation, or at least condition them. So that's kind of been the bit of background thinking and talking to producers about. So I think about in 2018, we joined a partnership that had been developed between New South Wales DPI, UNE and CSIRO with the MLA donor company called the Livestock Productivity Partnership. and we came into that partnership at a later point with the University of Melbourne. And it was the whole idea of the partnership was to bring like projects together and to start working across projects in a more collaborative way to increase the benefit to livestock producers in the end. So that's where this current project that I'm going to talk to you a little bit about stems from. So our project is focused on growing red meat productivity through the selection and establishment of perennial legumes. So that's our title. At the start, we decided that we couldn't be one thing to all people, and we decided to focus on two areas in Tasmania, one a high rainfall zone in the northwest and one the low rainfall in the Midlands. And we decided to do that because then we were talking to producers with similar values within those areas. We were able to get better farmer engagement because the work that we're doing is more relevant to them rather than having a whole of state thing. People within those regions can often be hotbeds for innovation, so we thought that they might be more adept to change, and that we'd identified some environmental constraints within those areas that we thought we might be able to work within. So in developing the project, we had a lot of interviews with farmers and spoke to them about a range of things. So within the Midlands being a low rainfall environment and a climate that's getting, I guess, more erratic. They were talking about failed sowings and legumes not persisting, that there was risk in establishment, and that focusing on getting legumes into pastures was something that they were interested in. This is some work that Matt Harrison done, who's a colleague of mine and works in a sister project under the Livestock Productivity banner, partnership banner, called the Nexus Project, which hopefully you'll hear a bit about in future in future presentations. But this is some modelling that he'd done on pasture growth rates in the Midlands, so Cressy's northern Midlands of Tasmania. And what he was able to show was that over the last 20 or so years, we've seen this decrease in pasture growth rates in summer and then into autumn, but increased growth rates from winter and then into early spring. And that over that time, overall annual production was reasonably stable, although a little bit more variability. And this was being driven partly because of an increased heat index that was coming in the Northern Midlands, so the incidence of hot days, and that the pasture increase or growth rate increase in winter was being driven by a decrease in the chill index. So in broad terms, less frosts stopping pasture growth. In the northwest of Tassie, speaking to farmers up there, they were also identifying feed shortages in autumn and winter, and particularly for a place like King Island, that becomes a problem if you're not able to finish stock in a certain amount of time. The buffering being on an island is not there, so it's a little bit harder to move stock on and off in an efficient or a profitable way. It was showing, as I suggested, that there was a decline in growth during summer, and this stagnation, as I said, of growth rates. There was also seen a major issue was waterlogging in those areas in the high rainfall zone, and that was becoming a pugging issue and I guess a broader environmental issue, leaving pastures reasonably bare and I guess exposed to things like nutrient runoff and those kinds of things. And as I said, on King Island, while they were talking about this drop-off in pasture production in sort of early to midsummer. But what you're seeing here compared to the Midlands is this greater variability in annual production. So bigger swings in pasture production, where before it was very, I guess, even and quite regular every year in what you could expect. And again, like the Midlands, we were seeing this general increase in the heat index and a decrease in the chill index. So I guess general warming to a degree. So out of those two, we decided to focus on the establishment of legumes in dryland pastures. We identified the fact that there was low amounts of legumes in pastures, and in the dryland setting, there's certainly less. While there's fewer options in terms of legumes for growing in dryland pastures than what there are in irrigated, and the legumes that are persistent often take longer to establish and are harder to establish. So we decided that was the area that we're going to focus on. We're going to focus on establishment of mixed sward pastures, but with a focus on legumes, knowing that they are probably more vulnerable than the grasses in mixed swards. So our project was had 5 main aspects to it, and so like I said, the first part was around the establishment of perennial legumes in the Midlands. So starting totally from scratch, doing a full renovation, whether that be through cultivation or direct drilling or what, and I'll explain a bit more about that shortly. How the second part was a series of experiments of, okay, we've got a grass dominant pasture. It's functioning quite well. How can we improve the feed quality of it? We don't want to take the risk of starting again. How do we get legumes growing back in that without taking the risk of wiping it all out? Third aspect was around waterlogging tolerance in perennial legumes, and we're going to be focusing on both glasshouse and small plot work, and then taking that through to trying to find legumes that are going to grow through that autumn winter period and be tolerant of winter wet conditions. So that's probably the first 3 years of the 5-year project. And then the last part of the project is taking the findings from these series of experiments, to partner with farms and try and take that to scale on farm. Try and take some of the risk out of it for farmers to try that, and partner with 10 farms to look at doing these things on a paddock scale. So main part of my talk, I guess I'm going to focus on today, and what I was showing in the field a couple of weeks ago was the experiments that are currently underway. So we started with the re-establishment experiments because there was less preparation time required to get those in the ground in the first spring. We've got 2 sites where those experiments were sown, one at Fosterville at Campbell Town and one at Cressy a little bit further north on the Cressy Research Station. And again, in this experiment, what we're trying to do is trying to get perennial legumes into a grass dominant pasture and trying to do what we could to advantage that establishment of the legume component in that pasture. So with the experiment, there was a set of different treatments, and all trying to, like I say, advantage that legume. So part of the preparation work, half of the blocks were, or plots were, sprayed with a low rate of Roundup at 0.5 litre per hectare. What we're trying to achieve there was just to try and limit the vigour of the foliaris that was growing there. We knew that it wouldn't kill it, but we knew that it would take a lot of that leaf off and try and stunt its growth for a period while the legume was establishing. The second treatment was looking at different ways of getting the legume into the ground. So we've used 3 different methods there: direct drilling, strip tillage, and then broadcast. So broadcast was effectively just throwing the seed on the ground, spreading by hand. The direct drill was using our drill, and I'll show you that in a sec, just trying to have minimum tillage and put that legume in. And then strip tillage, which was a little bit more novel and has been, I guess, promoted a bit in the regenerative ag circles and building soil carbon in soils, both in in Victoria and a little bit through cover cropping and the like in Tasmania in more recent times, but also being done a little bit in Europe as well. So that was I guess the more novel sowing method. And then the species that we were working with were white, red, Caucasian and Tillage clover and lucerne. So there we've got probably 3 that we would recommend for the low rainfall, and then white and red's probably a little, white definitely is out of its depth, and then red is probably on the edge of its depth in terms of that low rainfall environment. And yeah, we're just following a split plot design. So this is how Fosterville looked in August. So like I said, pretty good ground cover, but really dominated by grass. You can't see any legume in there. And so what we're trying to do is just bring that legume component to it. So this is our direct drill that we often use for a lot of our evaluation work of our pasture species. So it's a 10-row drill with a cutting disc on the front, baker boot, followed by press wheels at the back, and row spacings are 150 mil. I should be able to get this to run. So this is just how it was going in. So it's just direct drilling 10 rows in those small plots. So the plots are about 7 meters in length. So the second machine that we were using was the soil key strip tillage machine. So we've we're able to get one of those from a local farmer who's been working with AgriProve out of the mainland, looking at soil carbon projects. So we're able to get that and see whether there was application at a more broad scale. Pasture systems look at it. So like the pictures sort of show you there, all it's doing is it's effectively a rotary hoe with very I guess reducing the width of the cutting tooth on it. So it cuts or cultivates a very thin band, about an inch and a half wide, in which the seed's meant to follow in behind. Now, the difficulty with a lot of our small plot work is trying to replicate how we get small plots to then mimic how it would happen at broadacre. And so with this machine being so large, how we put 7 or 8 grams of seed into a machine like that and expect it to come out in a regular or reasonable pattern in our blocks is a real challenge. So what we had to do was come back and hand sow it afterwards. So this is the machine running. Now, normally that seed would then be flowing down these tubes at the back and straight into that channel, and then they would be dragging a chain afterwards. But like I said, because we've only got small amounts of seed, we couldn't do that. So I had to then follow along doing this. So effectively just dropping that seed on the surface, and I think we've still got a little way to go in terms of being able to replicate the actual machine and how it would work in the paddock, but I can talk a little bit about that later. This was just a picture short while after sowing, just showing that those areas that we had burnt off with the herbicide treatment had worked. And so if you're kind of thinking of the difference between a small legume trying to get established within this sprayed out area compared to under a heap of canopy in competition here, that's probably a good illustration of what legumes are up against if we weren't able to control that growth. So these are just some pictures of some of that seed germinating within those. I think this is the strip tillage treatments where it was able to just germinate from the surface. I think going forward we need to find a way of trying to come up with better seed contact and covering that seed up, but that's something we're going to have to tackle in the next set of experiments. So this is a picture I took not that long ago, maybe a week or so ago, at one of our sites where we're taking off the dry matter and evaluating it. And so you can see, I think this is red clover in this instance, growing pretty well in these strips. What we have had in this sort of 4 to 5 months since sowing is very favourable conditions. We've had, I guess, that La Nina spin-off down here in Tassie, where we seem to have got reasonably regular rainfalls through spring and summer, and that's certainly advantaged that establishment of that legumes. I think if it didn't work this year, it wasn't going to work. Put it that way. Here's just some basic data from an initial evaluation of plant count, and so we've just broken it down into where we've applied the Roundup and where we hadn't. So there's not a lot of difference at that first point. I don't think it's significantly different. But what we did see was that the plant counts from a direct drill and strip till were certainly significantly higher than the broadcast, or at least the direct drill was significantly higher than the broadcast at that point. What we need to do now is go back in autumn after we've had those plots grazed and do another frequency measure to see what is really there now. Number of plants, looking at species as individually is a little bit misleading because of differences in sowing rate and different sizes of seed. So it's really not that good to be comparing between the two in terms of the number of plants, but in what I would say is that the vigour of the red clover has been quite good. And these are just some more figures around, herbicide application by species. And again, like I said, looking at species at this point is a little bit trivial because of the sowing rates and what we'd be hoping for. What tells us the story is, really dry matter and cover in a year or two's time. That's what we want to see in terms of differentiating species. And the other thing, and just to say, is that in those areas where we didn't apply the herbicide, we took that yield of that pasture off in November, and that was just in line with how farmers would have been grazing that at the time. And so what we're able to do is look at what that potential yield penalty is if you were to apply that Roundup or that herbicide or follow through that practice at that time. What are you going to miss out on in terms of feed? So I think that was pretty important to follow up on. So that's that first set of experiments and where we're at with that. So we've just cut those again, and we'll have more data as it comes online. The other thing that we're looking at in the other experiments is just the waterlogging tolerance of perennial legumes, and we've done a little bit of preliminary work on that in previous years. And so this was just some work that an honours student had done, looking at waterlogging or the effect of waterlogging on these species. So in each of these cases, you can see that while the plants were still growing, they were severely impacted, particularly in their root growth and then their ability to grow above ground biomass. So in each of those species, even in white clover, which likes the high rainfall, was still quite stunted from that waterlogging event. And then looking across at something that we knew was a lot more waterlogging tolerant in the strawberry clover. So each of these pairs was a different accession or selection that we'd been working on. And you can see how that difference in above ground yield is significantly reduced, and quite comparable even under the waterlogging. What you do see is a real change in root structure. However, you see a lot more adventitious or lateral roots close to the surface, and some of those primary roots that were deep then start to die off under waterlogging conditions. It's just very well adapted to waterlog conditions. It's able to pretty much grow on the surface if needed. When that soil profile fills up and all the soil pores push all the oxygen out, and oxygen becomes really really in short supply, it's able to then get the gas exchange closer to the surface. As part of the work we've done of TIA over a number of years, much before my time, has been around developing different legume species for the low to medium rainfall environment. And a lot of the work has been really focused on persistence under I guess, or really low rainfall and traditional grazing. But we hadn't done a lot on evaluating dry matter, and certainly hadn't done a lot on evaluating them under irrigation. So we had a very large evaluation, or two evaluation experiments that Cressy set up, one under irrigation, one under dryland, to look at those legumes. And this is a photo that we took of the site now 2 years ago, after a really dry summer, or really dry winter and summer really, looking at those plots, and as you can see, lucerne was being able to access water deeper in the soil profile and had maintained decent ground cover, whereas something like strawberry clover or white clover, there weren't that many plants there, which is to be expected to a certain degree. We had an honours student then come through last year and look at how those plants were using the soil profile, and this is a soil profile from that site, and quite typical of the Northern Midlands region, where you've kind of got this duplex soil arrangement with a sandy topsoil horizon sitting above a medium and then a heavy clay, which means that during winter these soils can become waterlogged if we get big rain events. And particularly on land where it doesn't have any relief or slope, water can sit there and then become quite a problem for waterlogging. This was some of the data from his measurements that he did there, and so frequency is just a measure of plant cover within those plots. And so he took two different frequency recordings, one at pretty much the end of summer and after a period of 1 to 2 years of below average rainfall, and then another one in August, following a really good autumn-winter growing season. So what we saw was that the lucerne and Tillage clover were maintaining a reasonable amount of ground cover, or at least there was frequency of plants were there. But things like white clover and red clover were minor. And then in the second bar in each of those, particularly for white clover and strawberry clover, unless red clover to a certain extent, you can see them then starting to grow back and fill out those plots after we'd had a decent autumn and winter period. White clover probably not to the extent where you go and use it, but strawberry clover seems quite well adapted to be able to then survive those dry times, but then adapt to the wet times, or certainly more favourable conditions. The decrease in Caucasian clover is more a function of that not being active in winter, so that's not necessarily a case of persistence there. As I said, with strawberry clover, you see as it starts to spread, it starts to then root from these stolons that run across the ground and then form, so I guess, daughter plants or expand the main plant that way, so it can spread out vegetatively. vegetatively. What he was looking at and what he was trying to do was kind of correlate some root measurements to the actual why the plant's persistent, and what he was looking at was root diameter, and what he was showing was that the greater the root diameter, generally ended up being that the more tolerant, more drought tolerant things were. And so certainly the lucerne, the Tillage clover, and the Caucasian clover and red clover had a much greater root system, and particularly large root system in terms of how I guess wide those roots were going down. And I guess it's easier to explain it in this regard here. So what he was saying was that the persistence of those plants, or the frequency over time, the plants who were at the higher end of that actually had a significantly higher amount of dry weight of those roots, and that makes pretty common sense really. If we've still got live roots there, and a lot of them, and they've got a lot of dry matter, and everything's working well underground, well then yes, we're going to have more plants above ground surviving during that time. And finally, this is just from that data, you was able to kind of draw this diagram of how those legume species were acting in that soil profile during that time. So as you can see, the lucerne was, and he was only able to dig to 50 centimetres with the machinery or equipment that he had. So many of these roots will be penetrating well beyond 50 centimetres, maybe up to a metre and a half, depending on the layers underneath. But what we're seeing was that those, particularly the lucerne, the Tillage clover, Caucasian clover, were able to penetrate those medium to heavy clays at the bottom, and by doing that, we're able to access moisture that allowed them to be a bit more persistent during periods of moisture shortage. And then you look across to something like white clover, which is, while it's got more roots, they are very heavily, I guess, represented in the top A horizon. So this was some interesting work, just confirming what we're able to see. Now, what we're hoping to be able to do going forward is just showing what having deep-rooted species in a pasture then allows. So these soils can become compacted, and having a legume that is able to drive its roots down through those heavier profiles then potentially opens that space up for water infiltration, other roots growing down deeper into the soil profile, and just starts to alleviate some of those impacts of, I guess, compaction, whether it be from animals or cropping over time. So those are the kinds of things that we're hoping to investigate as we go forward in our experiments. So that's probably enough from me at this point. Like I said, that's a bit of a snapshot of the major project that we're working on, and some of the other I guess, relevant research that that I'm currently undertaking with our research group here in Dryland, and I guess for the benefit of our livestock industries here in Tas.
Thanks very much, Rowan. That was good. We have about 2 minutes for questions. So
sorry.
No, you're right. I think
you should have shut me up.
No. Well, people came here to see you, not to listen to me. So, and you've given us a lot, and we will make that presentation available. We do have one question here, which someone got in early, so I'm gonna pick it up. Yep. Did the nil herbicide prep use livestock to graze back the grass? You may have answered that a little bit later, but I'm not sure. So
the grass was grazed off prior to, in that first picture, to get it back to a very, very low level. And then the herbicide was applied after that. We probably went in, because of contracting, we were left scrambling a bit in terms of preparation time, and I would have liked to have been there probably 2 to 3 weeks earlier. So the picture where you saw, or the videos where you saw the legume going into, you know, a decent sward there, I would have liked to have been in there with a lot less pasture residual being there, but we were just up against it in terms of prep time. It's certainly something going forward in this next year that we'll hope to be going into a lot lower residual biomass there.
Okay, good. Sorry, I was just about to ask you a question and someone flashed up something. So look, we really are at time and there are a lot of questions coming through.
Yeah.
Can you give me rapid fire? I'll do a rapid fire.
Yeah, go on.
Okay. Okay, what is the pH of the soil at the trial site?
It's about 5.7.
5.7, okay. There's a few more in there coming through, but
most of our dryland pastures down here are somewhere between 5.3 and 5.7, 5.8. So they do see response to liming.
So what I'll do now, do you want to take the plunge and make yourself available for questions if people have them?
Sure. Yeah.
Is that okay? So
yeah. Shoot me an email or whatever.
Yeah. So, and your email's available. We can make it available, but also if you're happy with that.
Sure.
So if people do have questions, I'm sorry about that, folks, but we are sort of duty bound to keep this to a quickie. And I know that my colleague Emily Jones. So thank you, Rowan. Thank you very much for that.
You're welcome. Hopefully everyone found it interesting. And sorry I haven't allowed enough time for people to ask me the questions and.
Oh no, you're right. I think
jump in with criticism.
Well, I don't know. We can't. The downside and the beauty of this sort of format is that you can't hear a lot of feedback, but no one's complained. So people are saying thank you. So we will leave it at that, and this presentation will be available for folks, and also you can get in touch with Rowan directly. So Emily, would you like to say something about what you're up to in Tassie?
I would. Let's just get the slides up. Perfect. So g'day everyone, I'm Emily. I'm Farmers for Climate Action's new community organising cohort, and thanks to Rowan for a really good presentation. It was very interesting and it was great to see so many of you tuning in from across the country. If you enjoyed today's webinar, there's great news. There'll be more of them. So this was just the first in a series of Tassie Climate Smart Grazing sessions. We don't have any more scheduled just yet, but we will let you know when the next one is scheduled via our website, as well as our social media pages, Facebook, Twitter. And Claire, our wonderful policy and partnerships, she will send you an email as well. So we also, if we can go to the next slide, we also just wanted to make you aware of some really exciting new opportunities to get involved here at Farmers for Climate Action. So we're just about to launch our state and regional volunteer networks right across the country, actually, but particularly in Tassie, New South Wales, Victoria, Queensland, SA and WA initially. So these networks are going to bring together farmers and rural Australians, and really anyone who has an interest in the area, to improve climate outcomes in their communities and beyond. So there's a really wide range of volunteer work to do. And there's work for everyone, really. It doesn't matter what your skill set is, how much time you have to offer. We really do need all hands on deck. You know, you can be as involved or as little involved as you like. And it's just a great way to connect with your fellow farmers and rural Australians and make a meaningful difference in this area that so many of us on this webinar would care a great deal about. So to sign up, you can follow the QR code that you can see there on your screen. It'll take you to the Join Us page on the website. Otherwise, just Google Farmers for Climate Action and click Join Up, and you should be able to just fill out the form. Next slide, if that's all right. So we also have our Tassie network started up already. So if you're a farmer from Tassie or you live in Tassie and you're keen to get involved, let us know and we'll put you in touch with Ursula. Our next meeting is on Tuesday, the 9th of February at 2 p.m. via Zoom. So again, if you're keen to come along, you can email Ursula, who's our state coordinator for Tassie, at ursula@farmersforclimateaction.org.au, or just give her a call with the number there on the screen. Again, use that QR code to sign up via the website and our wonderful Ursula can get in contact with you. And we've also already got our Gippsland network up and running as well. So again, if you're keen, we have our first meeting on Monday, the 22nd of Feb at 2 p.m. So again, you know, you can email Ursula there. She'll be running the Gippsland network. And again, you can sign up via our website using the QR code. We also have some state coordinated jobs available. So they'll actually be running the networks that I was just talking about. They're part-time positions available in WA, SA and Queensland. And they'd really suit someone who understands agriculture and community organising and just enjoys talking to farmers. So please get your applications in soon. And if you know anyone who would be interested in this role or you think would be suitable in this role, get in touch with us and let us know and pass on the opportunity to them. Again, there's the QR code there. That'll take you to the position description of each of the roles and as well as the application form. So just fill that out. And again, please get that in as soon as you can. So that's all from me. Back to Corey to wrap up.
Yes, and I'll be quick. Look, thank you. Thanks very much, Emily. That's fantastic. It's really good to see FCA growing like that, and opportunities. There are more and more opportunities for farmers and also friends of farmers to get involved. FCA welcomes all comers. Look, if you've enjoyed this, do consider supporting us in some way, shape, or form. Doesn't have to be money, but you know, even just lending your voice. I often say to farmers that one of the most powerful things, next to doing some work on their farm, the most powerful thing they can do is to speak up and to just raise awareness. You know, a lot of them don't believe me, but there's good evidence to show that farmers, next to doctors, really are amongst the most trusted people by the public in this country. So we often underestimate, and farmers themselves often underestimate how powerful their voice is. So don't hesitate to do that. So thank you again. There'll be more of these. Stay tuned, and we look forward to seeing you again. Thanks so much for joining us today. Cheerio.